7.6 common logs. So what a common log is a basic log thing. So on most calculators, let me bring one up right here. You go like this. When you hit the log button, it doesn't give you a base. So that's a common log. So what is the base when they don't give you what is the base on a common log when they don't give you one basically? It's base 10. That's what it is. That's when we use so much that we just call it log. So anytime you see a log without a base, we should know inherently that's the same thing as saying log base 10. So, hey, let's say we're doing a problem and I said solve this. What you do is you go, okay, take the base of both sides, right? I don't have a base. Well, you know the base is 10. So you can take the 10 of both sides. These will cancel out and you get x equals 10 to the third or 1,000. That's a general idea. It's this: if you don't see a log, it's log base 10. So if you don't see a base, it's log base 10. So a couple of these you can do on our calculator. So they want us to do log of 7, right? So the base is 10. You're gonna show it. You get 0.845. There's 10,000. 10,000. 10,000. 1. There we go. Log 0.5. Likewise, you're just gonna go clear log 0.5. Hit enter. And negative 3.010. So like that. Okay, so let's go into why we use this. If you remember from a couple lessons ago where we learned how to solve exponential equations, where if I gave you like 2 to the x equals 8, all you had to go was, let's try to get these bases to match. So you go 2 to the x would equal 2 to the third. These bases match, x equals 3. Right? Well, what happens if the bases can't match? Well, you can't do this anymore. So what we do is we take the log of both sides. So we're going to go over here and we're going to take the log of both sides. So we're going to get log 3x equals log of 15. You're like, what good does that do? Well, what that does is, now you can see what my favorite rule is. Let's use our favorite rule to bring this x to the front. So you have x log 3 equals log 15. And now I actually solve this. I could divide by log 3. So x equals log 15 over log 3. Keep in mind this is not log 5. These are separate. It's log of 15, log of 3. I should be writing that all the time actually. Right? This is stuck. These don't reduce. Log that. Or if you want, you put in your calculator. Log 15. Make sure to close the parenthesis if you're going to do this. A lot of people forget to close the parenthesis. Get lazy. Divide by log of 3. And you get that. So 2.46 would be my answer. Again, I'm fine with that. I'm fine with just leaving it like this. Log 15 over log 3 is totally fine. This will show you again, guys. This is not the same thing as log of 5 because that's not the way log works. Log of 5 would be log 15 minus log 3. See, very different. You can't reduce that way. So that's the idea. Let's do another one, right? So same thing here. You're like, oh, I can't get these base 6 to the x 42. 42. There's no base for 42. So what we do is take the log of both sides because we can't find a log. So you can get log of 6x equals log 6 to the x equals log of 42. Right? Now I can move my x to the front. I'm trying to get better at doing that. It's log of 42. It's a function. Right? Then we get the x by itself, so you just divide by log of 6. These cancel out, you just get log 42 over log of 6. And that's it. Again, if you want, put in your calculator, solve it, but that's the general idea. That's what we solve all these. If you can't get the bases to match, you just take the log of both sides. You get log 5 to the x equals log of 55. Move the x to the front. Right, and then we want to get the x by itself, divide by log of 5. You get x equals log 55 over 5. Again, I cannot stress enough, these do not reduce. Don't give me log of 11. They're locked in. It's log of 55 over log of 5. That's it. Or calculator. 9b. So 9b, I'm actually use a calculator a lot because it gets really messy without a calculator. It still works. It's all the same rules. I can't get these to match, so what I'm gonna do is take the log of both sides. Now this time I'm actually gonna probably use my calculator. So I'm gonna get this. I'm bring all this to the front and bring this to the front. So I get b minus 1 times log. Notice it's all put together, right? B to 1, it's all one thing. Log of 9 equals b log of 7. So actually 2 ways we can do this. We use our calculator and figure out what these numbers are, and we're dealing with decimals all day. Or you can just kind of like use the log. So first I'm doing using a log. So let me distribute this. B log 9 minus log 9 times 1 equals b log 7. What do we next? We do the thing we always do. We want to get we're trying to solve for b, get all the b's on the same side. So let's move this, move that. So subtract b log 7 from both sides. Add log 9 on both sides, you're going to get this. Right, again, all I did was took the log. I can't get the bases matched. Took the log both sides. Lets you bring the power down. My favorite rule. So then you get this. It's me highlighting, not crossing out. Then I was like, oh, let's do some math. Let's distribute the log 9 of both of these. So I get b log 9 minus log 9 equals b log 7. Right, just basic algebra. Distribute, blah, blah, blah. Now, how do you solve for b when there's two b's? The same thing we always do. You get them on the same side. So let's move the b's to the same side. Move that over there. So we have this. That's where we're at right now. So I have two b's. How do I do this? You factor out a b. Equals log 9. And then we just divide by this. But we're pros. Remember what minus means? Dividing. So we're actually going to get, this is a long problem. B, right, minus sign subtract sign is dividing. Log 9 over 7 equals log of 9 on that side. Now you can just divide by this. Cancels out and you get b equals that monstrosity. So that's one way to do it, right? Just using logs. So I know it's a lot of algebra, but it's this algebra, right? You take the log of both sides, just put down the powers, distribute. Now it's just basic algebra. Get the variables on the same side, move the other stuff over there, factor out the variable you want. In this case, little log rules. You condense it and then you divide. Just basic math. What's the other way to do it? Well, using your calculator, once you got to this first step right here, you figure out what log of 9 is. So if you prefer, you can work with decimals. This would be 0.954, 0.954. And let's see what log of 7 is. Log 7 would be 0.845. So it would work the same way, just now you have like 0.959b minus 0.954 equals 0.845b. Right, same concept, just with ugly numbers now. You do it the exact same way. So I know it was a little bit of a mess, sorry about that. Let's move on to brighter things. Let's say we're doing this one. Right, let's say you want to solve this. Again, bases don't match. We're going to take the log of both sides. That's when we move this power to the front. I get x squared log 15 equals log 110. Divide by that. X squared equals log 110 over log of 15. Right, so the key thing to keep in mind is, oh, the bases don't match. Take the log of both sides. And then from here, you just get rid of the square. Square root it. And whatever that mess is. Again, putting your calculator like that, I don't care. Your life. So let's talk about how to solve exponentials that can't have the same base. don't have the same base. What we do is we use the same strategies. It's the exact same rule. Remember, we don't have to worry about we don't have to worry about domain here because domain on exponential, the domain of this is all real numbers. So I don't have to worry about the domain. Just solve it like normal. So the bases don't match. Take the log of both sides. That says log, right? You're gonna get log. Let me write it. So it's so ugly. 2 to the x greater than or equal to log 6x plus 1. Right, and we're going to solve this the same way we always do. We bring down these 2x's, bring down the powers, my favorite rule. I'm going to get 2x log 3 is greater than or equal to parentheses x plus 1, very important, log 6. Now we just did one like this. How do we solve it? Well, you could either put this in your calc and get decimals and work with decimals, or you just do the math on it. X log 6 plus log 6, 2x log 3. And then, I was like, I have all this stuff here. You want to get the x's, since you have two variables, you want to get them on the same side. 2x log 3 is minus x log 6. Subtracted this from both sides. It's going to equal to log 6. Factor out the x, that's the key here. So you get 2 log 3 minus log 6. It's greater than log 6. Right, then you can divide by that. Or if you're really pro, simplify this first. That goes up there. You get you get log 3 squared, which is 9. So this is 3 squared, also just known as 9. So you can condense that and you get x log 9 over 6 is going to equal to log 6. And then you can simplify that, divide by that, and you get x is greater than log 6 over log of 9 over 6. Never said those were pretty. Those are always quite disgusting. But that's the idea. Again, I can do the same thing here. This is another exponential question. You just solve it the same exact way. Take the bases don't match. Take the log of both sides. Bring the powers down. You have to do a little mathematics like I did here. And you'll get your answer. The key thing is, right, if you're doing exponentials, domains are real numbers. You don't have to worry about check. I mean, you could check your work. It's always a good practice, but it's not required. So, next thing is how about the change of base formula? That is, if you have a calculator, how do I figure out what this is? So some of these logs, right? Remember we talked about how to do this by hand. If I gave you log 381, I would expect you know how to do that by hand. You go 3 to what power is 81? And you go, okay, that's 3 to the 4th is 81. So I expect you to do some of these by hand. But sometimes you can't. 5 does not go to 31. Just 5 to what power equals 31? There's no power that's nice that works that way. So how do we do this? Well, we use a calculator. And there's a change the base formula. Very simple formula to use this in your calculator. Right? Because if you bring your calculator up, it doesn't really have, you put log, it's automatically base 10. I gotta turn this thing on. If you put log, it's automatically base 10. How do I put the base? So what we do is this. Very simple. You just separate it. Make 2 logs. This is the base. So it goes in the base, the bottom, the basement. So log base 10 of 5, a common log. And then same thing with 31. Log base 10 of 31. So that's how we figure these out on our calculator. So if I want to do this in my calculator and I don't have it, because I can't do it by hand, you just break it up. You can do log of the top one, divide by log of the base. Don't forget to use your parentheses. And you get 2.113. By the way, the same thing would have worked with the one I expect you know by hand, right? Log base 3 of 81. If you went log of the top one, 81, divide by log of 3, we should get 4. 4. Right? That's how we do it. Now there's another way. If you have an updated calculator, if your calculator is all the way updated, if you go to math and you scroll down, so you run these are all our math operators, to log base right there. So if you go to math, scroll way down, log base, then it kind of already does it for you. Hey, there's a place to put the base. So that's the easiest way of doing it. A little cheating, but whatever. And you get 1.95 if you're going to the nearest hundredths. So again, 2 ways to do it. The change the base formula where you separate it. The top goes on top, the basement goes to the basement. And if you just go to math and go to log base. Another way of doing it. So we can use the same idea here. right? We just talked about how to do this. Now I'm gonna show you like a small shortcut to doing this one. So z minus 4 equals 6.3. Now remember last time we did this, we took the log of both sides. Now if we want to be cool about it, we can take the log base to both sides. So let me explain what I mean. So this is log. I'm trying to solve for this variable here. So I'm gonna take the log base 8 to that side. If I take that to this side, I'm gonna do the exact same thing over here. And why is this a shortcut? Because remember how happens if they match? They cancel. So you just get z minus 4 equals log base 8 of 6.3. Then you can add the 4 over. Now remember, it's plus 4. This is locked in. Doesn't do anything. You can't add it there. Just on the outside. So z equals log base 8 of 6.3 plus 4. That's your answer. Let's do another one. This one's a little messy. Let's do another one a little more basic first. So let's say I give you log. Ooh, that's not the idea. Let's say I gave you 3 to the 2z equals 10, right? Again, bases cannot match. Not going to happen. The shortcut way of doing this, instead of taking log both sides, bringing them dividing, is just take log base 3 to both sides. You want to try and get rid of that 3 there, so do this. These cancel. I get 2z equals log base 3 of 10. And then get rid of the 2, divide by it. Again, this is locked in. So my answer here is going to be z equals log base 3 of 10 divided by 2. Not log base 3 of 5. These do not reduce. This is all one thing. It's all locked in. I should really put parentheses. So that's the idea. This one's the same thing. It's not going to get any prettier though. You can do log base 7 or log base 52, right? Which one do you do? You got to pick one, and it's not going to be that much prettier. It's just kind of a mess either way. But that's the general idea. And we're done.